In WireShark, we have two places we can go to begin capturing and select our capture interface. The first location is on the menu bar by clicking Capture, and you can see that we have this listing here: Interfaces, Options, Start, and then we can look at capture filters at this time. But if you use WireShark a lot, you're not going to be going to the menu bar. You're going to be using these first three buttons on the left-hand side. That's really the fastest way to begin capturing. Now, that's the way I'm going to be doing my capture, and let's take a look at these first three buttons. The first button will allow us to look at the available capture interfaces. Those are the ones that WireShark sees, and you can also tell whether or not there's any traffic that's visible to those interfaces by clicking on this button. The second one would allow us to start capturing using one of those interfaces, and we can define things such as capture filters, and we can define the capture buffer size and things like that. The third button would just automatically start a live capture using our global preferences. Now we're going to look at the adapter information first, so I'm going to click on the first button to list the available capture interfaces. When this window pops up, you should see a listing of the interfaces on your system, including a dial-up adapter, your Ethernet adapter if that's what you have there, and any 802.11 adapters. In addition, if you have a cellular phone adapter on your system, you would be able to see that as well. Now, even though I'm not capturing, I could see how many packets per second visible to this network interface card, and the total number of packet count since I opened up this window, and the IP address associated with that network interface card. Now, if I wanted to start capturing on that card, I can click the Start button right away, and it will immediately start capturing using the global preferences that I've set for that card. If I wanted to change some of those preferences and assign a different capture filter, or say that I wanted to capture to a file, let's say, then I would choose the Options button. Not many people go into the Details button, but it's interesting because it can show you when there are potential problems with your local card. So I'll click on the Details button. There you can see it pops up. And my card, I didn't even know this before, but my card actually only started up in 10 megabits per second. Apparently, the link that I connected into here, when it did its auto negotiation, it negotiated down to 10 megabits per second, which is not ideal. But this is easy to see when I pull up this information. Now, one thing to note is that all of these statistics are being gathered by the network interface card driver, and they're being piped up to WireShark, and WireShark is relying on that information and hoping that it is accurate. So this information is only as good as the network interface card driver information. Now, also on this window, you'll see the transmit block size, the receive block size, and the maximum packet size. Interesting thing with that is that we see 1514 bytes. On an Ethernet network, we would expect to see 1518 bytes, but remember that the last 4 bytes of the packet, the CRC value, are placed on the packet by the network interface card, so we don't see it at the driver level here. It's been stripped off on the way in and has been placed on the packet yet on the way out. So that's normal to see 1514. Now in the statistics area, again, remember that we're pulling this information from the network card driver. And the drivers won't necessarily pipe up all of this information, but it is available to see if it does pipe the information up. And we can click on the 802.3 tab to see the network interface card address. There's my card, there's the address, the permanent station address, and the current station address. And we can also see any sort of errors that would be piped up by the driver at this time. So this is a great area to look at in WireShark. And remember, if you're not sure how many adapters you've got or whether they've even come up properly and WinPCAP sees them and WireShark sees them, just click on that very first button and you should be able to see packets visible to that card if that card is working. Okay, this probably isn't one of the top features that you'll use with WireShark on a regular basis, but you should know how to do an unattended capture to disk. I do recommend that you are very careful when you use this option because you could fill up a hard drive very quickly. And also I don't recommend that you save your files to a server because then you're sending that traffic back across the network and you can become part of the network problem if maybe the network's just too busy at the current time. So good analysis does not send any packets on the wire. It's a totally passive process. There are two places you can go to set up capturing unattended to disk. First is on the menu bar to select Capture, and you can see we have interfaces and options. And where you're trying to get to is the options area there. That's ultimately where you want to get to. So you want to go to any place that can take you to the options area. The other thing that you could do is use either one of those left-hand buttons, the first button that lists the interfaces, we know there's an options button on those, or the second button over, which takes you directly to the options area. Now I'm going to use the second button and go directly to the Capture Options window. Now, the first thing I'm going to do is I'm going to make sure that all my capture information is correct on top, that I am using the correct adapter. And if I did want to apply a capture filter, now would be the time to put it in. So we can do unattended captures looking for only DNS traffic, or unattended captures looking at traffic to and from Fred's machine, or whatever you want to do. The area we're interested in is this capture files area right here. Now you should be aware that there's another area underneath there that allows us to stop capturing, but we're not capturing to a file on a disk, we're capturing into buffer space. And we could say we want to start capturing and then stop after a certain number of packets, or after a certain amount of disk space has been used, a certain number of megabytes or gigabytes or whatever, or after a certain amount of time, seconds, minutes, hours, days, things like that. But we're focusing on this top portion here. And the first thing we'll do is we're going to capture to a series of files in this example. And the first thing we've got to do is we've got to find where the file should be saved. So we'll click the Browse button and then give it a file name. Now the file name will just be a stem of a file name. It will be the beginning of the file name, and WireShark will append a number and then a date and time stamp after each one of those. Now, if you don't want to capture to multiple files, you could uncheck this selection and say, no, I only want to capture one file, and it will use the buffer size information up above to decide when to stop capturing. In addition, if you do say multiple files, you have to say when you want the next file to be created. So after a certain amount of disk space, so 1 megabyte, 2 gigabyte, whatever, or you have to say in time. You want the next file to be created after 10 seconds or 20 seconds or something like that. Now the ring buffer is interesting because what it will do is it will do a first in, first out on the files and save a maximum number of files that you define right here. So the way this is configured right now, I will capture, and each one of those trace files will contain 10 seconds worth of information, 10 seconds worth of packets that cross the wire, and after it fills up the first file, it will create a second file. And after the second file, the 10 seconds goes by on the second file, it will go back to the first file and begin to override it and keep counting up though. We could use the ring buffer, or we could just say simply that we want to stop capturing after a certain number of files. So let's say I only want to capture 5 files. And that's what I'm going to do. I'm going to start out by saying that I do want to use multiple files. And just for this example, I'm going to say, the next file will be created every 10 seconds. And I'll be able to toggle over to the directory window so you can see what that looks like. And I do want to stop capturing after 5 files have been created. Now the first thing I'm going to do is I've got to give it a file name, and I've got to pick the directory that I want the files to be saved in. So I will click Browse, and I have a directory already created called Trace Files General. If the folder that shows up in here is not the one that you want to save it into, you can click this little plus key in front of Browse for other folders and select the folder that you want to save your files to. Once again, I don't recommend that you save them to a network drive. I'm going to give this file set a name of test-file save. And I'm going to put in the PCAP extension. Now if you don't put in the PCAP extension, WireShark won't put it in for you either, which means that if you look at the files in the directory, they won't be associated with WireShark, so you can't just double click on them. So I highly recommend you put in the .pcap extension. Click OK. We can see now the file information is in there. Looks like everything's set up the way that we want it to be, so I'll click on Start. Now WireShark is capturing packets in the background, and I want to show you the directory structure of where they're saving the files. There we go. There's the first file, and then 10 seconds after the first file is created, there's the second file created. And 10 seconds after that, we should see the next file. Now you can tell how WireShark does its naming convention. There's the stem at the beginning that I created, and then we see the 0001 0002, 0003, 0004, and 0005 will be the last one, and then it'll automatically stop capturing. We have the year, 2007, we have the month, January, we have the date, 19th, and then we have the time. Yes, I can't believe it. It's 10:04 p.m. and 58 seconds and 09 seconds and 20 seconds and 31 and 42. You lose a second in there when WireShark does its saving to the drive, but you're not losing those packets. Now, if we go back over the WireShark window, we can see it's showing us the last file in that set. If we had been dropping packets, we could look down in the bottom of that WireShark window and we could see that it would say you've lost packets, you've got drops. So look at this area here. Now there's a separate training module talking about how to deal with working on an overloaded network and what kinds of things you could do. But this is always a great indicator right down, looking at your drops to see if you're losing any packets. So we can see that we've got the last file of this 5-file set showing in WireShark, and each one of them is separate and each one of them has a timestamp. So you can go back to just the file that was saved at the time you were interested if you have a whole listing of them. If you said save 100 files with 10 minutes apart, you don't have to open up the whole entire set. You can open up just a smaller piece. And remember, the smaller the files, the faster WireShark will open them up. So don't make a 2 gig file, a 3 gig file, or something like that. Try to keep them small and nimble. Now I'm going to click on the Capture Options button, and I'm going to do one more unattended automatic capture here. This time I will say that I want to save the file every 1 meg, and I'm also putting in that I'm going to save the file every 10 seconds. Now what will happen in this case is WireShark will focus on whichever one of these criteria was met first. So if I can get more than 1 meg of packets that I can capture in 7 seconds or something like that, then it will stop and make a next file. But if I don't get 1 meg in 10 seconds, then it'll automatically create a new file 10 seconds later. Once again, before you start capturing to disk, be careful. Be careful when you say you want to save. Don't pick up something like, I want to save 5 files and I want every file to be 10 gig. You're just going to fill up your hard drive too fast. And also, try not to save your trace files to the server because you don't want to be part of the traffic. Good analysis is done in a passive manner. Using a ring buffer can be really nice because it'll help avoid filling up a hard drive with all these different separate files. And you may only be interested in the things that led up to a certain event. So maybe you really only care about the traffic that led up to when the server crashed or something like that. So you can use a first in, first out ring buffer style of unattended capture. Again, just like in doing our regular unattended capture, you have 2 places you can go to set this up, and one would be to do this under the capture interfaces or options area, or to use the buttons in the background. And I prefer to use those buttons in the background. So you'll see I'm going to click on this Show Capture Options, and there's the Capture Options window. Now again, I'm going to check and make sure that the interface that I want to use is listed up above, and if I wanted to place any capture filters on this before I started, all the capture filters are defined as well. Now I've got to define the name of my file and say where my files are going to be kept. So I've got a trace files general directory, and I'm going to call this test-ring buffer. I'm going to give it the pcap extension just as I did before because, like I said, WireShark is not going to put that extension on these files, and I do want to make sure that I can associate the files with WireShark, so I can just double-click them in the directories. I'll say OK. Now I am going to use multiple files, and in this case, just to show you as an example how this looks, I will say that I want each one of the new files to be created after every 10 seconds, but instead of stopping the capture after 5 different files are created, I'll use a ring buffer, and I'll do a ring buffer with 3 files. So in total, at any one time, the most number of files that I'll ever have, the top number of files I'll ever have will be 3 files. When the third file is filled up, it'll go back and start overriding the first file. So everything's ready. I'll go ahead and start capturing. Now we can see that WireShark is capturing, and I'll toggle over to the directory now to show you those files being created and being overwritten. There we see the first ring buffer file, and now we're already on the second ring buffer file. And when that's finished, it will create the third ring buffer file. And I will only have 3 files that start with test ring buffer, but these numbers are going to change because the one that has the 0001 is going to change and be overwritten to become 0004 in a moment. And there we go. We can see that now ring buffer 0001 was just overwritten, and in a moment 02 is going to be 0002 is going to be overwritten and become 5. So that's the way the ring buffer works. And it is really nice because we don't have to worry that, oh, by mistake, maybe I will have filled up my drive. You can use both the ring buffer and the maximum number of files at the same time. Let me show you what that looks like when you do that. We're going to go back over to WireShark, and now we need to manually stop the capture because we didn't say a maximum number of files that WireShark should record before stopping. So I'm going to manually stop, and in the background it's showing me I only had captured 1 file in the 8th file capture process through the ring buffer piece. Now I will say that I want to show the capture options again. This time I'm going to use a combination of the ring buffer, saying I want 3 files, and stop capturing after 5 files. Now in this case, I'm going to browse, make sure I'm saving these in the right directory. I am. And this is going to be called another test ring buffer.pcap. Say OK. So now I'm using a combination of the ring buffer with a static maximum number of files to be saved. I'll click Start, and I will toggle over to the directory window. And here we can see another test ring buffer 0001 was just created. Now it's just created 0002. Keep those together. And in a moment we will see 0003. Now remember, I said that I wanted 3 files in the ring buffer for a maximum of 5 files. So 0001 is going to be overwritten in just a moment here. There we go. It just became 0004. And in a moment we will lose 0002 as it gets overwritten by 0005. There we go. Now I've reached the maximum number of files that I told WireShark I wanted to save. It will use a combination of the static maximum number that I set of 5 and the ring buffer value of 3. So it's got 3 files left in there and only counted up the 5th file in the set. And we can see that we're left at the last file in the set. So although you won't do that many unintended captures to disk, and you possibly may not use the ring buffer that often, it is one of those nice things to know how to use when you need to use it someday. File sets are used when we're working with a series of saved files, just like the series that we created a moment ago when we saved to the ring buffer, or when we saved a series of 5 files. If you just open up a trace file that's just a standalone trace file, such as this one that's called Another Lousy Hotel Network 2, if I go under File and select File Set, you'll see that the next file option and the previous file option are grayed out. And if I click on List Files, I will only see this one file. Now, if I open up a single file out of a set that I've saved, such as with the ring buffer, or saving multiple files to disk, then I will see a list of files involved in the file set, and I can move around very quickly through those files. So, for example, if I say I want to open up the trace file general directory, and in there, here I see let's look at this one called test-filesave, and I have 1, 2, 3, for 5 files that are part of that set. If I opened up the second one in that set, now we're looking at the second one in the set. Now I go to File, go to File Set. Now you'll see that I have the ability of looking at the next file in the set, the previous file in the set, or I can select List Files, and it'll show me all the files that are in the set, as well as the size of the file, when it was created, and when it was last modified, if it's been modified at all. Now this is nice because if I want to look at the fourth file in that set, all I have to do is click on that file and it takes me directly to that file. There's the third file in the set, there's the first file in the set. Now, of course, this works a lot better when your files are not really, really large in size. So when you do set up your system to create file sets, you say you're going to use multiple files and create a new file every so often, make sure that the criteria that you select does not create 10 gig files or something like that, because you'll notice then if you're opening up a file set and you're moving from one 10 gig file to another 10 gig file, of course it's not going to be nearly as fast as it is when you're moving between a 1 meg file or a 10 meg file or something like that. Capture filters are used when we want to limit the number of packets that we're capturing when we place the analyzer on the wire. For example, we may want to capture only ARP traffic, or perhaps we only want to capture IP traffic, or maybe we only want to capture traffic to and from our own network interface cards. That's one of the most common filters that I use in the area of capture filtering. We can see the default list of capture filters that are included in WireShark by selecting Capture, and then the Capture Filters area right here, or we can select the Capture Filters button on the button toolbar. Here's the predefined list that comes with this version of WireShark. As I highlight each one of these capture filters down below, we can see the filter name and we can see the filter string. So the nice part about having these predefined filters is that they give us a basis to work off of if we don't know the syntax for capture filters. So we can get a general idea that if the filter for an ether type 8060806, which is ARP, looks like this, ether space proto space 0x0806. If we know that there's also a filter that we want to build for IP and that value is 0800, we know we can edit this and easily change that value. We don't even have to make that filter because there is a default filter looking for all IP traffic. And we can also use not operands in these filters, and we have an example there. So not ARP. We have an IPX filter, a TCP filter, a UDP filter, TCP or UDP using port 80. Simple. Just type in port space 80. HTTP, TCP port 80, and here you can see that in the capture filter area, it's already been predefined with the protocol, TCP, the port, and then HTTP instead of 80. So with the standard port numbers, 80, 23, 21, 110, and those kinds of things, you can replace the port number with a port name as long as WireShark recognizes that name. So you can go through and you can see that there are also some sample filters that are more complex, such as this one, which is non-HTTP and non-SMTP traffic to or from www.wireshark.org. And here's the syntax down below. Not port 80 and not port 25 and host www.wireshark.org. Because we have the AND operand in there, the traffic must meet each one of these individual patterns in order to be picked up and saved in the capture buffer. As we scroll through, you can see that is the last of the samples that are in this version of WireShark. If we want to work with the default set of filters that are in WireShark, in the upper left-hand corner, we can select Show the Capture Options, bring that window up, and in the Capture Filter area, we can just select one of those filters. So I do not want to see any ARP traffic. So I have selected No ARP, say OK. It's placed it now in the Capture Filter area, and I'm ready to start capturing. Now here, as traffic comes in, we should not see any ARP traffic being saved. I'm going to toggle over right now to a web page, and I'll just browse around a little bit to create some traffic. So I'm over on the WireShark web page. I'll go to the facts area. I'll go to the documentation area, and then I'll go to the wiki page. Now I'll toggle back over to WireShark, and we can see by the capture window here that we have some TCP packets, some UDP packets, ICMP packets, but we did not capture any ARP packets. We'll go ahead and stop, and we should see no ARP traffic captured or saved at all during that process. Let me show you where your capture filters file is. The capture filters file resides under your login name, application data, WireShark directory, and there it is. It's a C filters file, which is just basically a text file. It has no extension. If you want to open it and take a look at it, you can right mouse click, say that you want to open it. It won't know what application to open it with, so I'm going to scroll down and open it with WordPad, say OK, and there's our capture filters file in plain text. If you do ever go in and edit these, just remember that after the last line that you type in, you must hit enter to give it a control or a carriage return line feed at the end. So luckily there are a number of capture filters already pre-built for you. In the next section, we're going to go through and create some brand new capture filters. Now I'm going to create some brand new filters for WireShark. The first filter I'm going to build is a filter I use all the time, which is called a My Mac filter. It will capture all traffic to or from my hardware address. So when I'm testing out an application or I'm working on a network that seems to have some problems in communications, I can easily pick up my own traffic. Now I'm also the victim of the problem on the network, and I can look at the trace file and know exactly what keystrokes I typed in order to send that traffic, and I can correlate problems with different events that happen. So the first thing I'll do is go up to Capture, Capture Filter, and here are all of the default capture filters. Now instead of typing my filter in from scratch, I'm going to click on the Ethernet address filter at the very top and click on New, and it's made a new copy of that filter down at the bottom. Now I'm going to edit the name and just call it My Mac. And I must edit the filter string so that it matches my hardware address. So my hardware address is 001636A90820. I'll click on OK. Now if I go back in, just by clicking on OK, it's also saved that filter for me. So it's an applied save, and there it is down below. At this point, I can click on Show the Capture Options, click the Capture Filter button, and select the filter I just created, say OK, and start. Now, any traffic that's generated to or from my hardware address will be captured with this trace process. I'm going to toggle over to a web page and create some traffic in the background. So I've just brought up the WireShark web page, and I'll scroll down and let's click on the documentations area. And we can see in the background, just clicking there, created 15 packets to or from my hardware address. I'll scroll on the left-hand side and maybe go to the developer information area, and we can see that I'm generating some traffic. When I'm done with this, I'll minimize out that window, click Stop. And when I look at the traffic and I look at the hardware address area in every one of those packets, I should have my hardware address either in the source or the destination MAC address field in all of those packets. So as I scroll through, we can see there's my hardware address over here, there's my hardware address over here, etc. Now a lot of times people make mistakes in the syntax area when they build capture filters, and I want to make a mistake now and just show you the error message that will come up. So first of all, I'll get rid of that trace without saving it. I don't need it. Go over to the capture filters area. I'm going to make a mistake in the My Mac filter. Common mistake people make is that they will put a dash in between the bytes instead of a colon. When you click on OK, there is no warning at this point, no error checking on the creation of capture filters. There is error checking when you try to run that filter. So I'll click Show the Capture Options. Now it's still got the capture in there that I had before. So I'm going to select the new incorrect capture filter. There it is. We can see that there's the mistake in there. I'll click on Start, and here's the error message that comes up. It says, I'm sorry, that string isn't a valid capture filter. Bogus Ethernet address. And you can see that it's having a hard time because I put a dash in there. It tells you to look at the user's guide for information on how to define the capture filter syntax. So if I click OK, go back to my capture filters list, I know that that capture filter has a problem with it. Don't forget that you have a help button here. When you click on the help button, it will bring up the help window that shows you the syntax that you can use with your capture filters. Now you can also edit your capture filters file. Now the capture filters file is loaded at the time you bring up WireShark. So the best way to do this is to close WireShark down, go in and edit the capture filters file, and then reopen WireShark. So let's go ahead and do that. I'll close the help window. I'll go ahead and cancel out of this window. I know that there's a mistake in there. Cancel out of that window. And I'm going to close WireShark and edit the capture filters directly in the file. And here's where the file sits. It's under your login name, application data, and then the WireShark directory. You'll see the C filters file. I'll right mouse click on that file, say I want to open it, and I'm going to open this with WordPad. Say OK, and here's the file. It's basically just a text file, and it's just a very simple little text file. We can read it. You can see whatever's in quotes here. That's going to be the name of the filter, the capture filter, and then after that you have the filter syntax. Now the last one I created, I know had a mistake in it, and I can go in and edit this mistake right here. Oops, I better not edit it and put in another mistake. My Mac, correct. I'll just change the name of that. If I wanted to create a new capture filter, I can cut and paste one of the existing filters in here, or just type in the filter I want to create. You must always make sure, though, at the end of the last filter that you have a carriage return line feed. So I'm going to go to the My Mac correct filter here. I'm going to Control C to copy it, and I'm going to paste another one in. I'm going to make sure I hit hit Enter at the end to give it a carriage return line feed. And let's say this next one is Fred's Mac filter. I don't like it being called correct, so I'll get rid of that. And I'll put in his hardware address, which I'll just put in a bogus value, 1122334455. There we go. So there's my 6-byte address for Fred. I'm just simply going to make sure I have a carriage return line feed, and I do. I'll save that file, close it down, and now I'm going to restart WireShark. WireShark is back up. I'm going to see if my new capture filter for Fred is in there. Scroll down through the list, and sure enough, there's Fred's MAC address. Now in this version of WireShark that I'm working on, there's no sort capability in the filter area, and that can be really irritating. So one of the things you can do is you can take that file, that CFilters file, into another application, sort it, but just as long as you make sure that when you finish it's just a text file with no extension and it does have a carriage return line feed at the bottom, then you're set. There may be times when WireShark can't keep up with the traffic. In that case, when you look at the status window as you're capturing, you'll be able to see the drops counter increasing. In that case, there are a couple of things you can do. First of all, when you begin capturing, make sure that you get rid of the check mark in front of Update List of Packets in real time. That can really have a negative effect on your performance. In addition, make sure that you don't have too many other applications running in the background. A couple other things that I do is I get rid of the Enable Network Name Resolution area there, because I don't want to be spitting out packets inverse name queries in the background while I'm trying to go through and capture this traffic on a very busy network. Another thing you could do is go into the Edit Preferences area, and inside of this area, in the capture area, you can see this is where we can globally get rid of the Update List of Packets in real time. But also another thing that I'll do is I'll go into the protocols section. And under TCP, if the majority of the traffic will be TCP, I might get rid of things such as analyze TCP sequence numbers. I might also get rid of the relative sequence numbers and window scaling area and the reassembly process. In addition, in many cases, I'll get rid of the TCP checksum validation process. Sometimes in my traces, I will see that all the TCP checksums are invalid anyway because that checksumming process has been offloaded to a card. So these are some of the areas that I might turn off to streamline WireShark. Now there's additional information that you can get on streamlining WireShark in the WireShark directory. You need to go into Program Files. Underneath the Help directory, you'll see a file called capturing.txt. I'll right mouse click and open that with WordPad. Now in this file, as you scroll down, you'll see a section called High Performance Capturing. And that gives you some idea of what you might want to do. And you can see it recommends get rid of the Update List of Packets in Real-Time option and close other applications. There's also a recommendation in here to not apply a capture filter. And there's a rule of thumb area in here. So if generally I capture all the traffic and then work with display filters after the fact. The last bit of information it will mention is that you might want to get a tool that's just dedicated to packet capturing and only use WireShark to display the packets. One of those tools is included with WireShark and it's called T-Shark, and we can run it at the command line. Now T-Shark is in the Program Files WireShark directory. Here, I'll show you where it is. There we see tshark.exe. If you need information on how to run T-Shark, you can type tshark-h and the whole list of parameters comes up for you. In section 10 of this course, you'll get additional information on running T-Shark and the other command line tools that are available with WireShark. Now it's time to test yourself. This lab will require connection to an HTTP server. And if you'd like, you can print out Appendix A, which lists the WireShark lab exercises for this course. In step number 1 of this lab, build and apply a capture filter for all HTTP packets to and from your MAC address. You'll want to save these packets to a directory called tests, so you may want to make that directory first. You'll save these packets in 30-second trace file sets with a maximum of 5 files in the set. You're not going to be using the ring buffer in this exercise, so make sure that you're not going to be overwriting packets during the capture. All of your trace files should be named starting with my_HTTP and have the PCAP extension on them. Once you've set everything up, begin capturing and browse to an HTTP server. Now you'll need to browse for enough time to fill up all of the 30-second trace file sets. So this will take at least 2.5 minutes to complete. Once you've finished, stop browsing, go back into WireShark, open up and verify your trace file sets. Now would be a good time to pause the video to complete the lab. And when you're ready to see the lab and the results, restart the video. Now the first thing I'm going to do in this lab is I'm going to define a capture filter looking for all traffic to and from my hardware address, but I only want HTTP traffic. I shouldn't get any ARP traffic and I shouldn't get any DNS traffic. So I'm going to use an existing default filter, the default capture filter that's already set up called Ethernet address, and I'm going to click New. Now I have a new copy of that filter and I'm going to change the name of it to My Mac HTTP Only. And in the filter string, I'm going to make sure that I put in my actual hardware address there, 00:16. I'm going to make sure I put in those colons there because I know that it won't take the dashes in between each byte. I'll put in the Boolean operand and I'll put in port 80. Now I could have just typed in HTTP there and it would have understood. I'm done with that and I'll say OK. Now I'm ready to set up my capture. Bring up the capture options window. I'll select the capture that I just created. There it is. I'll say OK. Now that capture is in there. The first thing I need to do now is give it a file name and put it in the right directory. Now I don't have a tests directory yet, so I'll have to make one. So I'll click on Browse, and then I'll browse for other folders. And on the root of C, I'm going to create a new folder, and I'm going to call it Tests. Say OK. And now I'll give the trace file set the name my.http, and I'm going to make sure I put the pcap extension at the end so that every file in the trace set will have the .pcap. That way it'll be associated with WireShark, so I can double click on any one of those trace files and open them up quickly. I'll say OK. Now I can validate that I've got the right directory name, I've got the right stem name for all of the trace files in the set, and that they'll all have pcap at the end. Now I do want to use multiple files. I am doing these files every 30 seconds, so I'm going to change this to 30, and click the drop down arrow and select seconds. I do want to use a stop capture file maximum number here of 5. So there are my 5 files. So far everything looks okay. I've got the right adapter. I've got my filter defined in there. I've got the right directory, the right stem name. I've got the right extension. I'm using multiple files. Every file will be created after 30 seconds from the file before it, and there will be a maximum of 5 files. I'm showing that I've got update list of packets in real time on right here. And just for performance sake, I'll uncheck that. I'll unselect that for this trace process. Now, when I click Start, WireShark will begin capturing. And I'm going to go ahead and fast forward you in time so you don't have to wait all these 30 seconds while I do some downloads in the background. Now, I've sort of fast forwarded you in time. My WireShark is still capturing. I'll toggle over to the directory structure to see where I am. So there's my tests directory. I've got trace file 1, 2, 3, 4, 5. I'm going to toggle back to WireShark, or let's just hop over to WireShark in the background. There we go. Looking at WireShark in the background, so it hasn't finished yet with capturing trace file number 5. When it's finished with trace file number 5, it'll automatically put it up there. It'll be the last one that I'm viewing. So there we can see in the background it just changed, and this trace file is now closed as far as adding new packets to it. So I'll go ahead and minimize the directory structure, and I can see there I'm in trace file number 5. I've got my HTTP at the beginning, I've got pcap at the end, and now I want to validate my 5 trace files in the set. So I select File, File Set, and list the files. And there are the files in the set. Now, if everything went well, I should not be able to see any DNS queries or any TCP ARPs or anything like that going on in the trace. And I'll check on the very first trace file to make sure that I don't have something like that, because most likely that would be at the beginning where I would see a DNS query before I make a handshake to a website. And there are no DNS packets in there. Just to validate that, I could also go under Statistics and look at the protocol hierarchy and make sure that everything falls under HTTP. And sure enough, everything falls under HTTP here, so that looks good.